Hi, good evening, everyone. Hello, I'm audible. Hello, good evening. Jai Hind, everyone. I'm audible. Please confirm. Okay. Good evening. Jai Hind, everyone. I'm audible. Please confirm. Okay. So today, very exciting topic we are going to cover, and the topic name is test bench. Okay. I'm just going to give you the brief exposure, like brief, or you can say in detail also. That is what is test bench and why it is required. Okay. Okay. Let me connect my system. Okay. So I'm still focusing on uh, gate level modeling. I'm still focusing because it is not like that key in online live recording class or in live classes like online instructor led. I cannot go back again. Okay, so what I am planning here, I am covering every aspect of the coding so that you should not have a single doubt that you have or I have not covered anything, right? So from digital, we have started, we have implemented the logic brainstorming sessions, then something on logic building, then we have started with the project discussion, then calculator. For calculator, we have identified one small adder, then from adder to 4-bit adder and then 8-bit adder, and same thing we have implemented on tool. Then we started with Verilog, introduction of Verilog, and in last class, last few classes, I also discussed like uh, about implementation on FPGA. Okay, I've also shown you the complete flow. We discussed about the FPGA flow also, and then we started gate level modeling. And yesterday also we have covered the gate level modeling. So today I'm going to cover the test bench. Okay, okay. So what is basically a test bench? Okay, right. So I have prepared some points for you. I'm going to discuss one by one. Please try to understand because I can explain these things on our screen also. So later on, I will show you and I will design something. I will write some code and then we will verify it. Okay. So the question is here. Question is here. What is test bench? So let me first explain it. A test bench in a Verilog is a piece of code used to test and verify the hardware design module called DUT design the test. Okay. So okay. So used to test and verify the hardware design module. Your hardware design module is just, for example, in last few classes we have covered adder, half adder, full adder, up to anything. Okay, up to any small logic, big logic, anything. Okay, so here means that we have to test our hardware logic. Okay, that is called basically a design. A design, whatever the design you have prepared, that is called a design under test. Okay, so suppose that in last few classes I have designed a full adder, okay, and or we have designed something with respect to the gates, whatever. So that is called basically a design. So we have to put our design under test. So that is called design under test. So it is not the actual hardware. Okay. The meaning of this line is basically whatever you are going to design it. Okay, that is a virtual simulation. You are verifying it. Okay, you are not generating the any netlist for that, or any hardware schematic for that, or any synthesis for that. Okay, so this is very much clear. The test bench is not giving any hardware with respect to the gate level. Okay, then it is the only used in simulation to check whether design works correctly. See, it is clearly mentioned here. I have 100 of inputs. I have 200 of inputs. I cannot force it one by one, as I have mentioned in simulation in last few classes. Okay, if you have 100 of, if you have a 25 or 20 also, right? You have to force one by one for every prospective uh, solution. Okay, let me try this, let me try this, let me try this. You cannot force it every time. Right click, force constant, right click, force constant. If you are following my classes, you know what is the force constant. Okay, so you cannot force it every time. It will take too much time. Because 20 data, 20 input, 30 input, you cannot force it. So what is the best way? Write the piece of code and change the value in the code only. And change the value in the code only. So it is you don't have to open every time a force constant page. Okay, and then click OK and apply, click OK and apply, force value, click OK and apply. No, it is not like that. So test bench is easy, okay, to write, to understand, and it makes really life easy. Okay, so it is only used in simulation to check whether the design works correctly. Okay, next slide. What is test bench again in HDL? Simple definition. Okay, with help of test bench, we will generate some random inputs. See, generate rand input signals. Okay, these input signals basically it is a part of our code only. Okay, for example, in half header, the input signal of my half header is A and B. Okay, the input signal of my half header is A and B. So output header is A and B, C in. Okay, so basically we have to generate some signals. Applies stimulus to the design. Okay, so what is stimulus? It is a value. Okay, it's a forcing values. So we have to force some values to our design under test. Okay, we have to push it some values. Okay, what basically we do then? We observe the output. Okay, if you all remember that in last few classes, from the starting from the design of half adder to 8-bit adder, we are basically forcing the value and we are testing it. Okay, you know that it is a very hectic job. Okay, if you remember 7 times A value and 7 times B value, we have to force it. Okay, so and then we see the output, that those green color. So basically we have to see the output. Now after that, what basically we achieve? So we achieve the functionality of my design. We achieve the functionality of my design. Then before implementing the design on FPGA, okay, this is also very true that whatever we are designing, okay, ultimately we have to convert into the hardware. That is some gate level netlist. If we don't convert those design in a gate level netlist, okay, you cannot run anything on FPGA. So in summary, whatever there is a engineering team, and there is a verification team, the small level verification team, okay, on FPGA side, not on the VLSI side. So whatever the FPGA people are designing, the verification team or himself or herself also, in parallel they are going to design the test bench or write the test bench to verify the output at every single input, whatever he or she can think. Okay, so you cannot think, suppose that if you miss anything while forcing the value, okay, but Is there any value not giving the output? Okay, at some aspect, you cannot identify uh, with normal simulation. So with the help of this behavior, with the help of this test bench, you can basically debug it. Okay, so this is the whole definition. A test bench is a generate input signals, applies stimulus to the design, observe output, check the functionality before implementing on. So you are not going to implement the test bench on FPGA. You are going to implement the main logic part on FPGAs. Okay, next. Right. So let's take one simple example. Like I have taken example of simple calculator. Okay, that suppose that I'm going to design a chip which is of calculator. So before manufacturing, you want to test 2 plus 3, 5, and 5 minus 2, 3. Okay, etc. Right. So the environment that gives input and checked output is called the test bench. So I know that this is my chip, and this chip has a 4 input A and 4 input B, and this gives the output in 8 bit. And this is a sign. So whatever someone has designed, I want to verify it. Okay. Let's take an example. This is a simple example. You don't need to worry. We will going to write it. Okay, we are going to, and just this is I'm just taking an example of AND gate. Okay, I'm going to take example of AND gate. Okay, so this is the design of AND gate, a simple behavior level modeling. This is a gate level modeling, sorry, and this is a data level modeling. I have not discussed till date, so ignore this slide. So you have a AND gate. Okay, you have a AND gate A and B, A and B, and this is your Y out. Okay, so whatever you are giving the input, you are getting the output. So as we mentioned, at in gate level modeling, we start with the N1, that is your instance name. This is your library, that is your gate. You're calling, this is your output, and this is your input and input. Okay, so what? So how we are going to write the uh, how we are actually how the test bench look like? Okay, see, I will write the code for you. We will discuss the line by line. Just for your information, how the code basically look like. See, so in test bench, first of all, we don't write the input and output. So here input and output is missing. Not missing, it is not required. Why? Because in test bench, basically uh, we are not forcing the value from outside. Okay, so it is something like this. You have a unit under, you have a test like this is your DUT. Okay, so some DUT have your input and some DUT have your output. Okay, so this DUT we have to put it under the test environment. Okay, so uske liye you have a input, means whatever the input you have in design, the same input you will generate outside. Okay, just to force the value textually, and the same output will generate outside. Okay, so that is why we don't require the uh, inputs. Okay, then reg A and B. This is very important. What is reg here? I have not discussed till date about the reg. Reg is basically a variable. Okay, it is same thing just like in C. What is variable? Variable will store the value and change the value as per the input and goes to the output side. Okay, so basically store the value. Okay, for some time unless until new value came and exit for some time. So that is the purpose of reg here. Why we are using this reg here? Because actually in textual information, we are forcing the value. See here, we are forcing the value. Okay, we are forcing the value. So for some time being, the data will be stored. Okay, so to store the data up to the 10 nanosecond, what is required? Required are some variable which is actually a part of the Verilog. So reg is basically a variable which store the value unless until new value came. Okay, so this is called reg. Okay, right? Prajwal, which reports you are talking? I'm not sure about the reports. What about the reports? Okay, So you please identify, please clarify. Okay, so this is basically a, this is how basically we have given the value, different value. Like one time we have given A0, B0, then we have given 0 and 1, then we have given 1 and 0, and then we have given 1 and 1. Okay, so basically, if you remember in Verilog simulation, we are forcing the value for gate A and B 0 0 0 1 1 0 1 1, and then we are identifying the outputs side by side. Simultaneously, we are identifying the output also. Okay, so now in that case, we are just writing it here and we are just simulating. We will get the output side by side also. Mean to say that up to 10 nanosecond, we will see what is my output when you have input 0 0. Then next 10 nanosecond, we will see what is my output if we have input 0 1. Next 10 nanosecond, we will see the output if we have input 1 and 0. Okay, so don't need to worry. This again, I am telling to my every students, this programming is not a theoretical subject. Okay, this is 200% on laptop or on any desktop. You have to write it and you have to check it and you have to feel the that what error you are getting and you have to solve it. Okay, so but for your information, I am writing and preparing this slide so that you should have better understanding. Okay, while writing all these things, it is taking time. Okay, this is not a digital. Okay, in digital, you know that I have to make the circuit every time, right? So I cannot prepare the PPT of the digital design. Okay, but I can show you the PPT of coding because coding requires the textual information. So we write it and then we can explain it here. Okay, next. This is the simple. Okay. Oh, we have to reduce it. Okay, this is the simple simulation. What is simulation? The output is called simulation. Okay, so change inputs, wait for some time, and check the output. Okay, the same thing. Okay, so changes input. What happened in simulation? In that is in simulation. What happened in simulation? Basically, after every 10 nanosecond, your data change. That is C. This is after 10 nanosecond. Okay, then this is 0 1. The output is 0 after 10 nanosecond. Again 1 0 after 10 nanosecond, and etc etc. Okay, so this is basically your a basic understanding of the output. Okay, now what is test bench in again? What are the major components in test bench? You need to understand before writing the code. Okay, as I mentioned that you have to basically define all inputs. Okay, design under test. You have to identify the all inputs. Okay, so this is your basically input, and this is basically you have to define under reg. Okay, and wire. Why we are taking the output with respect to wire? Wire because wire generally don't stores any data. Okay, so in main behavior modeling, we basically define all outputs in reg. Why? Because in behavior modeling, the data is stored and then it performs read, write, etc. So for that purpose, data output is defined as a reg. But here in my case, in a test bench, the input is basically taking the values from the text information. That is why the data is stored in form of reg, but the output is keep changing. Okay, output is keep changing. Okay, it's not storing the value, so that is why the output is defined as a wire. Okay, so DUT instantiation. Okay, so here basically there are two types of instantiation. One is called position mapping. I will discuss. Okay, this is basically what this is your DUT, UUT, this is your DUT. Okay, so your DOT has two input, one output. Similarly, your unit under test has two input and one output. So basically, you have to connect your UUT inputs. Okay, you have to connect this with this with this, and this with this. Okay, so either you follow the position mapping or either you follow the this is called your I'm forgetting, maybe it's called pin mapping or okay, I will check. So basically, in position mapping, we will follow the position of my units of my reg inputs and my wire outputs. Okay, of my design under test. We have to follow the position. If the first position is output, then we have to keep output. If the second position is input, then we have to keep input. If again a third position is output, again we have to keep output. Okay, so that is called a position mapping. That we will take up. Don't worry. Okay, so first thing is signal declaration. That is your input and output. Second is your basically you're calling your uh, DUT or you're connecting your DUT with UUT. Okay, and then this is the third point. Basically, you have to give the stimulus with help of your inputs. Okay, you have to force the different value at different time. Okay, you have to force the value at different value at different time. So this is called a stimulus, and I have not started yet a sequential. Okay, so basically a sequential in sequential we need to generate the clock signals. So this is how the signal generated. Okay, so we will take up once I will start the sequential. Okay, why test bench is important? Okay, why test bench is important? This is very important. Why we are writing the test bench? Basically, these are the interview questions, my dear. Okay, whatever I have asked, what are the different components? What is stimulus? Why we are using reg? Why we are using wire? Okay, what is the what type of mapping we are use? How we are connecting DUT and E and UUT? So basically, these are the interview questions. Okay, so my this lecture is going to help you in clearing the interview questions. Okay, so what is the importance of test bench? Or why it is important? First, bugs remain hidden. एक minute. Okay, why test bench is important? Without test bench, okay, let's take on other side. Without test bench, if you are unable to find the bugs, then what the problem is going to happen? Your design may be failed after the production, then it will be a huge loss. Okay, so that is one simple aspect I'm telling you. Okay, I'm not saying that because of the test bench only it is failed, but because of many reasons it is failed. Okay, maybe the designers have cleared all the aspect. Maybe it's failed due in some in a STA stage or in synthesis stage or in PNR stage. Okay, or in a layout stage. Okay, or in circuit stage. At any stage it can be failed. But just for your reference, without test bench, you don't know if you fail to identify the bug, then it is a problem for us. So why test bench important? Because we need to identify the bugs with the help of test bench. Second, hardware may fail after fabrication, then there is a huge loss and debugging becomes expensive, right? So at that time, it is very debugging has become expensive means after the production or during the production, if you come to know about the problem, then you know that a company has to invest a lot of things. So that is why the verification is a very important part of the VLSI and FPGA industry. Okay, important point. Test bench has no input output as I mentioned. Basically, TB this as I mentioned because you are basically you are basically not you are basically testing your device, okay, from the external source. So that is why we don't require the input and output. First thing, okay, is a top level simulation model, and it's not synthesizable hardware. Okay, already I have mentioned. So basically, you have designed something DUT, and now this this UUT is basically known as a top level. Okay, so this is called basically a top level simulation module, which don't have its own input and own output. So basically, you are giving your hand to connect to hold someone. Okay, so if you don't required, if it is not required, your hand, then it is of no purpose, right? And third, the design is not synthesizable, definitely, because it is basically for a simulation purpose, right? We don't require we don't expect any uh, output in terms of gate level from the UT. Okay, so simple. This is one thing. This is one thing, and then simulation flow. Let As I mentioned, test bench applies input. Test bench. Okay, as I mentioned, this is my test bench input. Okay, which is called UUT, which is apply input to my DUT and give the output. Okay, to the output port. See, same. The test bench apply input to my DUT and give the output to my simulator. This is very simple. Okay. Okay. Interview definition. What is test bench in Verilog? As I mentioned, Testbench is a non-synthesizable Verilog module used to verify the functionality of a design by generating input stimulus, applying to the DUT, and observing the output during the simulation. Same thing, input, stimulus input through UUT goes to the DUT, DUT perform the logic, and then output comes through wire. Okay, that is simple. Okay, then important terms. Just for you remember, I'm using the word DUT. What is DUT? Design the test. What is stimulus? Input test patterns. Simulation means virtual execution of hardware. Waveform means signal timing display. And verification means checking the correctness. Okay. So very simple. Just for memory point of view, just to recall, just to remember this thing, that what is design module is the actual hardware. Okay, and what is test bench? Virtual test for hardware. Okay, so if I say here again, this is my DUT and this is my unit under test. Okay, or you can say this is your test bench. Okay, anything you can say. Okay, so this is about the theory part. Let's uh, let's take a one example and of let's take a one example of writing the test bench of a full header, whatever we have written here. Okay, so let me. Okay, okay. So suppose that, just for example, I'm just uh, module my FA. Okay, sub C out. Okay, it will be my module my FA sub C out A B and clear. Okay, if you remember that I already used clear. The purpose of clear is to clear the design. Okay, So please remember this. You have sum, C out, A, B, and clear. Okay, please remember this. Okay, then uh, input is A, B, and clear, and output is your sum and C out. I'm still taking care of. I'm still designing the full adder with help of the gate level modeling. I'm not disturbing you and not confusing you to writing the any other module. Okay, then you know that. Suppose that uh, if I recall the hardware, if you know the hardware, okay, this is your hardware, right? Okay, this is your hardware, correct? You all remember, correct? And then we have, okay, we can write it, we can write in a gate, in a data flow also, but it is going to confuse you if you don't know the what is gateway modeling. Okay, then we have connected this with one. Okay, so this is your clear. Okay, and let me write it because you need this thing. You basically you need the code. Okay, and then your AND gate, your AND gate, your AND gate. Right. This is your A. This is your B, and this is your C in. Correct. And this one line is connected to C to clear this. Correct. Okay. And then this is your final sum, and this is your final C out. Okay. So I'm just helping you to recalling the others once again. So this is your wire W0, W1, W2, this is your W3, this is your W4, W5, okay, W6, W7, and this is your W8, okay. So you know the input outputs, right? Module my underscore FA, sum, C out, A, B, sorry, A, B, and clear, right? Your input A, B, and clear. Okay. Output sum and C out. Okay. And then wire W0, W1, W2, W3, W4, W5, W6, W7, and W8. Okay. This is my wire. Correct. And then I will start calling all gates. Okay. So let me call one by one. This is and N1, W0, A and clear. Okay. And N2, W1, B and clear. Okay. Then and 3, W3, C in and clear. Because to because this is basically my DUT. Okay, design under test. We have to test this. Okay, we have to test this. Correct. Now this XOR N4, W3, and we have W0 and W1. W0 and W1. Then we have this again XOR this XOR. Okay. and actually we have W9 also, right? We have to write W9. W9. Okay, this is my W9 basically. Okay, I forget. So we have another XOR. This is N5 W9. Okay, W9, W3 and W2. W3 and W2. Okay, then this OR N6 output is W7, input is W4 and W5. Okay, and then this again OR, you have a N7, you have output is W8 and input is your W7 and W6. Okay, then you have finally you have last two AND gates. Okay, AND gates. This AND gate is your AND N8 sum W9 and clear. W9 and clear. Okay, and then again you have AND N9 C out W8 and clear. Okay, and then AND module. So basically what you have done here, you have designed one you have designed your logic with help of your logic of your full adder with help of your gate level modeling. Okay, now we have to write the test bench for this. Okay, we have to write a test bench for this. So for this, please remember the position. Okay, sum at first, C out at second. So these two are my output. These two my are input. Actually, C in also. I forget C in also. C in and clear. Okay. So you remember that last one is your clear. Please remember this. Okay. Last one is your clear. Okay. Now, now I'm going to write the code of the test bench code of my design. Okay. So, for example, this is my full adder. Full adder has three input, two output. So this design, this DUT or unit under test or DUT, okay, you can say the UT also. This DUT is or UT is connected with the test bench, with the test bench signals. Okay, so test bench signal is, so this is your A, B or C in, this is your sum and C out. So this we have to connect with my test bench signals. Okay, like this. We have to connect with our test bench signals. Correct. Then module. Okay, we have to start with the keyword module. Okay, then my underscore FA underscore TB. Okay, so for better documentation purpose, if you write test bench TB, okay, it look very good actually. Okay, so okay, now what are those inputs you have? Okay, you have an input basically your this one your A, this A B C is basically your DUT inputs. Okay, so you have to connect your DUT inputs, okay, with your test bench inputs or test bench signals. Okay, so you have to define with help of reg. Okay, you can take like this A1 B1, okay, and C in 1, and you have a clear also, right? Clear, like this. And what is your output? You have a reg basically. Just a minute. So, so basically, uh, okay, now out is your basically sum and C out. Okay, so you can write your wire, okay, wire S1 and C out one. Okay, so you know that in your design, basically you are not worried about the wires because wire is actually a part of your full adder. Okay, now what? What is next? Now you have to call your design. Okay, so what is your design? Design is this one. Okay, so you have to call your design. Okay, so you have to call this one. This is your design name. Okay, so what I'm going to do here, I will call. So what is the name of my design? The name of my design is my underscore FA. FA is a capital. Okay, so I will my underscore FA, right? So I will write same my underscore FA. Okay, then UUT or DUT, write anything oblique. Now you know that your signals basically you have to write the in input and output. Basically you are mapping your DUT with the test bench signals. Okay, so you are basically mapping your test bench signals with the basically I can say with the DUT. Okay, you are mapping a test bench signal with your DUT. Okay, so the first one is your here. First one is sum, then C out. So you will write S1, then your C out one. Okay, and then you will write A1 because the third position is your A input A. Fourth position is input B, and fifth position is okay your input C in one, and last position is your clear if you remember. Okay, so here you have to maintain the basically this position. Okay, so there is one more. Okay, there is one more mapping. This is called basically a position mapping. Okay, okay. Suppose that this is a just a position mapping. Same I am writing up how you do the basically a pin to pin mapping. Okay, input to input mapping and output to output mapping. How you will do basically same. I am writing the same. So UUT. So in the position mapping, you have to make sure that the position should be accurate. Okay, this clear should not be here, this A should not be here. In that case, you will get a logical error. Okay, so you should make sure that the position should not be different. But in a pin mapping, okay, it's little bit always confused. Okay, it's always in that case you don't have to worry about the basically your position. Okay, you don't have to worry about the position. Okay, you have to just worry about the that you are connecting the right pin with the right pin or not. That is the right pin of the test bench with the right pin of the DUT. Okay, so for example, here it is my A1 and there is my capital A, capital A. Okay, so in that case, dot A1 A, comma. Okay, dot B1 B. Okay, I'm just writing. I'm not right. Okay, in this you don't have to worry about the position. Okay, you are not worry about the position. You just worry about that you are connecting the right test bench signal with the DUT signal or not. Okay, C like C in one dot. This is comma then dot with C in. Okay, comma, and similarly your S1 with sum comma dot and C in one. Sorry, C out. C out means the previous C out. That is my uh, C out one. is connect with my cout, comma, and again dot for clear. One should connect my clear like this. Okay, you can see here. I am not worrying about the position. Okay, I have written A here, then B here, then clear here and there. Okay, so both way you can try, but initially I will go with the first one. So it is very easy. Okay, for understanding point of view. Later on, if you have a good number of input and output, then you have to basically depend on this, because at that time maybe some position will uh, because this design is small, so you can easily identify the position, right? But in some cases, when you have a huge number of inputs, huge number of means you have a good number of inputs, like in 50, 60 terms, right? So sometimes it is very difficult to maintain the position. Okay, so okay, so I will remove this. Now I will start calling my inputs. Okay, I will start calling my inputs, and basically I will start giving the stimulus. Okay, so for that you have to call initial. Now what is initial? So basically initial is come under the is basically a procedure block. Okay, initial is basically a procedural block. Okay, procedure is basically comes under the behavior modeling. Procedure comes under the behavior modeling. There are two things. After the gate level modeling, there are two things: continuous assignment statement and procedure assignment statement. Okay, so procedural assignment or procedural block basically comes under the behavior modeling. Okay, so in that there is two block: initial and always. So inside the initial, basically we define the value at 0 nanosecond and it's terminate automatically at 1 nanosecond. Okay, something like this. Okay, it is mentioned there. Okay, so here in test bench, basically as we are forcing the value, so initial is also required to force the value. Okay, initial is basically also required to force the value. Okay, so here we will we will write it here: initial begin. Okay, now i want I want to give the I want to force 000 to everyone. Okay, and I know that clear is active at 0 and disable at 1. Okay, so what I will do here, I will write it A1 equal to 0, B1 equal to 0. I'm forcing the value C1 equal to 0 and clear equal to 0. Okay, suppose that if my clear is 0, if I'm giving this A1 B1, then what will happen? So after, suppose that I want to check the A1 if I'm giving after 1 nanosecond. Okay, after just clicking on uh, what we call uh, to initiate the waveform, we click on button. Okay, at a gap of 1 nanosecond. Okay, I will show you. Don't need to worry. So if I am giving the value 1, a key value I am giving 1. Okay, and I want to see the output at that time. Okay, so after 1 nanosecond, if I'm just changing the value of a, what will happen at that time? The आउटपुट क्या होगा उस टाइम पर, अगर मैं यहाँ पर क्लियर की वैल्यू को 0 ही रखता हूं और a को मैं वैल्यू चेंज कर देता हूं, उस टाइम पे आउटपुट क्या होगा? द आउटपुट शुड बी 0 because okay, it if any case if output is 1, that is called bug. ठीक है, why? Because we have not changed the value of clear from 0 to 1. Okay, so what is bug? At the same time you are writing the value here, at the same time you are seeing the output also. Okay, so suppose that if you are giving clear 0 and you are forcing the a is equal to 1. Okay, so if so the simulator will take the previous value. The previous value is still 0 of clear because we have not changed any value. Okay, before this hash 1. Okay, before this hash 1 we have not changed the value of clear, but we have changed the value of A1. Okay. So suppose that if I take again B1 equal to 1. Now again I will check the output. Why? Because now this B1, the value of B1 will add after 1 nanosecond. Okay, I will show you. Don't need to worry. Okay, so in this way, basically, we have to write the stimulus and check the output. So this is at 0 nanosecond to 1 nanosecond. Okay, this is at 2 nanosecond. Okay, and what will happen here? The this will also be changed at 2 nanosecond. We will check. Okay, so in this way, basically, we will give the stimulus value and we will check the output in a waveform. Okay, and then in the last, you have to write it and then end module. Okay, so this test bench you will only learn after writing the code. Okay, you have to test it at every point of at every point of the view. I mean to say that at every point, so that you should be very clear with your funda that you are not getting any bug. Okay, so now let's back to the screen. I will show you the how the design is actually look like in coding. Okay, okay, the tool is taking time. Okay, so yes, we have the code now, the same code which we have written there in on my screen. Okay, okay, so I'm not going to write the I'm not going to basically okay. So this is basically a gate level modeling using the two half adder. Okay, this code is basically a FA underscore clear with two half adder. Okay, so the DUT can be anything. It can be a single with a gate level, or it can be a with the help of two half adder. Okay, so I'm going to write a test bench for this. So I will what I'll do here. I will click. So this is my design window. Okay, this is my design window. This one from here to here. Okay, so it is divided into two: behavior and sorry, your hierarchy and process. So in hierarchy, you are getting all the files, and in process, basically, you are getting only the whatever you want to do it. Like for example, you want to do the simulation, synthesis, implementation, everything you will receive inside the process. So there are two options: implementation and simulation. Okay, so so for this select you can select anything at that time it's not required. So for this, right click, new source, select this Verilog module, write my FA test bench. Okay, FA test bench. Okay, write it and oh, click next, finish. Okay. Okay. Now, as I mentioned that we don't have to uh, write the inputs. Okay, so I'm not going to write the input. So my inputs are my DUT inputs are A1. Sorry, my test. Achha, here basically we have to write my test bench inputs. Okay, so test bench input. I will take A1, B1, C in one, and clear one. Okay, why 4? Because in my design, basically, see, in my design basically I have my 4 inputs. Okay, like this. I have my 4 inputs like this. Oh, sorry. And then so these are basically my test bench signals. Okay, test bench signals define as reg. Okay, now I will take my output. So as I mentioned that I will define my output with help of wire. Why? Because on output basically we have to share the information. Okay, we don't have to store and use it, right? So we have two output, sum one and carry out one. So I will write S1 and C out one. Okay, C out one. Okay, now we have to call my design. So my design name is FA underscore clear. Please note, I have to call this FA underscore clear. Okay, and then UUT. Okay, so basically TUT. You have to basically uh, this is basically your instance name DUT. Okay, and then the first one is output. Please remember, first one is output. C out A B C in clear. So I will go with the position mapping. So I will go with the position mapping. Sum C out A in B in C and clear it. Okay. So sum is my here S1 small C out one C out one small A1 B1 C in one. We have to maintain the position and last one is clear one. Okay, sorry, I have to write it clear here. Okay, and then semicolon and then initial. Okay, so basically here you have called this is your test bench. This is your output signals output, and now basically you have to start calling INI initial begin. Okay, so what I'll do, I will show you one by one. Okay, the simulation is I will show you one by one. Okay, so initial begin uh, A1 equal to 0. Okay, B1 equal to 0. Okay, and I will take C in 1 equal to 0. As you know that I will take 0, 0, 1 initially. Okay, 1 and clear 1 equal to 0. Okay, so and then okay, I will do one by one. Okay, okay, end module. Sorry, end module. Okay, let's save. Wow, see, check here. So this is my full header clear. On the top, you have a test bench now. Okay, FA test bench. Okay, see here. So this is DUT. This is DUT. See, the word DUT come here. Okay, now FA test bench. Earlier, before saving this, nothing is here. Okay, so FA is clear is my DUT and this DUT is called under the test bench. Okay, now let's simulate it. So you have to click on this F8 test bench and then check syntax. If there is any error, it will give you the error. Otherwise, it will take you to the behavior model. Right click, run. So I will give the stimulus one by one. Okay, for your understanding. Okay, so this, so you can see here, as I mentioned that the initial, whenever you declare the first values, the basically it start with 0 and end with 1 nanosecond. Okay, so that is why at 0 to 1 nanosecond you are getting A1 B1 C in 1. Okay, so A1 0 B1 0 C in 1, but at that time your clear is what? Clear is 0. That is why you are getting your output is 0. That is why you are getting the output is 0, and it is clear because your clear is active. Okay, so if you disable the clear, then you will get the output someone carry out 0. Okay, so let's see how. So what I'll do now, I will write hash 1 and I will write clear 1 equal to 1, and now I will show you the again output. Okay, so now what happened, up to 0 to 1. Okay, this line is up to 0 to 1, 0 to 0 to 1 nanosecond. This line is going to execute. Okay, now and this line is going to execute from 1 nanosecond to 2 nanosecond. Okay, but at the same time, what is the previous value of, what is the previous value of A1 B1 C in 1? Okay, so at the same time, what is the previous value of A1 B1 C1 is 0 0 1. Okay, so A1 is 0. Okay, let me make it here. Okay, use this comment line, use this forward slash to for comment purpose. C in 0 and C in 1. So if I am giving 0 0 1, in that case my sum will be 1 and carry out will be 0. Okay, so what I'll do, I'll close this. I will close this. Yes, no. I will close this and I will again go to the test bench. I will save it and I will again run. Save this. Go to simulation behavior model. See, we are not forcing the value there. Okay, the value is coming automatically. Okay, right, this one. Now you can see here. Okay, maybe okay. Oh, what happened? What happened to this hash 1 clear 1? I'm getting it is okay. If I take 2, basically values keep on adding. Okay, whatever the value you are giving after hash 2, basically is adding the delay. Okay, so let me check once again. आउटपुट तो आ गया. Okay, run. Okay, output, so we are getting the output, but I want the output. Okay, no problem. Let me try one more thing. Suppose that after hash A1 equal to 1 and B1 equal to 0. Okay, In that case, what happened? Okay, one error, hash one. Okay, let me try one thing. Uh, okay, okay, I got it. Basically, oh, okay, okay. See, I'm getting the value change here, but the problem is here. I got it. The reason is we have to use the dollar finish. Okay, see, the mistake I'm doing here. Uh, dollar finish. Okay, after two. Okay, I'll let you know. Hash hash two dollar finish. Okay, so basically I have to terminate it. Okay, that is why I'm not able to see the output. Okay, so okay. See, you can see here that up to see up to 0 to 1. Okay, up to 0 to 1. That is, this is line 0 to 1. Okay, the your input is A0, B0, C0, and clear 0. In that case, in that case, okay, please try to understand. In that case, before this, before any delay added, okay, or before any simulation input added, okay, before this, the output will be some 0 and carry 1. That is from here to here, some 0 and like this. Okay, you can see here, I am getting some bug here. Bug means after giving the clear also, a see, see, after giving the if this my clear is 0. Okay, correct. If my clear is 0, see, so my sum and C out is 0. Okay, so at 0 to 1 nanosecond, correct? Now I have added, I have given hash 2. Okay, that means this clear 1, this clear 1 will be 0 till 2 nanosecond, will be 0 till 2 nanosecond. See here. So this clear will be, okay, sorry. I'm just changing my word. That this means that 0 plus 2. Okay, 0 plus 2 means that at 0 plus 2, that means the clear will be initiate. The clear will be initiate. Okay, it will be INITIA, will be initiate at 2 nanosecond. Why? Because this line is basically started with 0 to 1 nanosecond, and I have given only clear 1. Okay, so you can see here. So this clear 1. So at the same time, when clear is deactivated, that is from 0 to 1. At the same time, What is the value of C in? The value of C in is 1. How? The value of C in is 1. Why? Because as I mentioned, the previous at the hash 2 means at the 2 nanosecond, right? The all the simulator will take the previous input. Okay, the previous input of A1, A, B, and C is C in is 1. Okay, so in that case, what happened? Your sum will be what? 1. Your sum will be 1 and your clear will be 0. Okay, again, now again after hash 1. Now the you have basically forced the value of A is 1 and B is 0. Okay, you have basically forced the value of A is 1 and B is 0, but you have not changed the value of clear. Please remember, you have not changed the value of clear. So in that case, what happened? In that case, the simulator will take the previous value. So what is the previous value of clear? Is 1. That is still clear is disabled. That means at 3 nanosecond, what will be the output? Your C in is 1, your C in is 1 because you have not given the C in also. You have not given the C in also in this line. That means after this or after this. So it will take the previous value of C in. It will take the previous value of C in. So C in is 1, B in is 1, sorry, A in is 1. Then in that case, your C out is 0. Your this one. If A is 1 and at 3 nanosecond, right? At 3 nanosecond, if A is 1 and C in is 1, then your C out is your 1 and sum is 0. Okay. And suppose that I am after this, I'm adding one more. I am saying clear is 0. Clear 1 is 0. That means I am after 1 nanosecond, I am disabling clear 1. Means I am giving clear to 0. Then what will happen? At 5 or 6 nanosecond, the clear will be 2 plus 1 plus 4. At 4 nanosecond, the clear will be 0. At that time, the whole output will be 0. Okay, so let's see. Okay, so check the right run. Let's see. Because of that finish, right, this two window is opened. Okay, so don't need to worry. Basically, you have used the command $finish. The finish means you are basically terminating the simulation. Okay, so let's see what is the simulation. You can see here 3. That is still your clear is 1. That is at 4 nanosecond, your clear is 0. Okay, so at 4 nanosecond, your clear is 0. That means your output is sum 1 and C out is 0. See here. Okay, and suppose that I want to enter here, what will happen? Again, I will do hash 1. I will give it clear 1 to 1. Okay, and I will give A1 to X. Now let's see what happened. Okay, let's see what happened. If I give A1 to X, let's see what happened. Okay, so basically you have to check the design at every single inputs. Okay, so let's see. Okay, some mistake I have done. One mistake. What happened? X is not declared. Okay, so but I want to give the value X. Okay, one tick BX in case what happened. Okay, so basically we can also force the value in terms of one tick BX. I will show you this thing in next few classes. Okay, what is one tick BX? Okay, don't need to worry. Okay, so let's see what happened. So now at 2 plus 1 3, 2 plus 1 3 4 5 and 6. Okay, that is at 5 nanosecond. Let's see what happened at 5 nanosecond. Okay, see, 0 to 1, when clear is 0, all output is 0. Sum and C out is 0. At 1 nanosecond, because clear is up at 2 nanosecond. Okay, so again your output is 0. At 2 nanosecond, you have disabled the clear. In that case, your C in is 1. So your sum is 1 and C out is 0. At 3 nanosecond, you have your clear is still disabled. Okay, and you have given two value. Your C in is 1 and A is 1. Then in that case, your output is C out 0 and sorry, C out is 1 and sum is 0. Okay, now at 4 nanosecond, okay, you have disabled the clear. Okay, you have disabled the sorry, you have enabled the clear. So in that case, your output is 0. So you can see here, your output is 0. Okay, and at 5 nanosecond, basically what you have done, you have given a key value x. So if you force the value in x in your design, okay, if you force the value x in your design, your all output will be 0. So that means your design is perfect. In if it is showing 0 or 1, that means your design is wrong. Okay, so if I'm giving x, I'm getting output x. Okay, you can visually verify with the help of x and z concept which we have discussed yesterday. Okay, now what I will do here, I will take again hash 1 and I will write it clear 1 equal to, I will make it 0. Okay, sorry, I will make it 0 and then I will again take hash 1 and this time I will take a in is 1 b1 is 1. I will take b1 1. So I have not given after 2 nanosecond, I have not given a to 0 and I have not given c to any values. Okay, so at 7 nanosecond, 2 3 4 5 6 7, at 7 nanosecond, the value of a will be considered 1 and C is considered as 1 because after 3 nanosecond I have not given any value to A and C. So the previous value will be considered. Okay, so let's simulate it. It is not easy to explain the test bench. Okay, test bench you have to learn from your own. Okay, write it, run. Our roadmap is very vast. Okay, I need too much time to explain each and everything. So, okay, where is my simulation? See, okay, see here. Oh, my A is still X, but my clear is 0. So if my clear is 0, you can see here, if my clear is 0, whatever the value of X, your output is 1. Your output is 0, 0. Okay. Now I'm going to change the value of again. This is my last value. Okay. This is my last. And I will make it to A1 equal to 1. Okay. Now let's see. Why it is showing 0? Because my clear is 0. Okay. So the power is still with clear. So I have to disable my clear also. Okay. So I have to disable my clear also. So where is my cursor? Gone. Hash 1 clear 1 equal to 0. Okay. Now 2 plus 1, 3, 4, 5, 6, 7, 8, 9. Okay. At 9 nanosecond, you will get, at 9 nanosecond, you will get A1, B1, C in 1, all 1. Then your output is sum 1 and C out 1. Okay, so let's save it. This is the last one. Oh, okay. So this is the last. So this is my last vector or last stimulus. Run. Okay, check syntax is correct. Correct. Run. So at 2 plus 1, 3, 4, 5, 6, 7, 8, 9. So at 9 nanosecond, your output will be 1, 1. Sum and C out will be 1, 1. Okay. See at see at 9 nanosecond. See at 9 nanosecond, your because you have disabled your clear from 8 to 9. So at 9 nanosecond, your clear is 1. So in that case, your C in is 1, your B in is 1, your A is 1. Then in that case, your output is 1, 1. Okay. So we have successfully implemented a test bench of full adder. So what I will suggest you, if you are following me, okay, then please sit for at least 1 hour, 2 hour, 3 hours, and go through each and every second video. Okay, and please work out. Please work out. That means please keep on working. Okay, please work out in your on your tool. Design it and verify it. Design it, verify it, because test bench is required, okay, in interview. And if you know how to write a test bench, there is you are not basically making any logic now. Okay, later on, if you are going to be a part of some training or some company, you will learn lot of things at what should we write inside the test bench also. Okay, so this is all from my side. I'm I'm really enjoying, okay, with this type of learning, because this is the first time I am doing here. Okay, so I request you everyone, please keep learning, because the India future is going to be very interesting in coming few years. Okay, a huge requirement of semiconductor is going to become. Okay, so before leaving, as I always mention, be disciplined. Okay, whenever you have decided to do this thing, please first complete and then move to the other topic. Okay, so this is all from my side, and thank you very much. Keep learning.